Hi, Mr. X with Glossary Term Three-Dimensional Coordinates. We have three basic systems that are used mostly. The rectangular form, pictured here, X, Y, and Z. The cylindrical form, with typically R, theta, Z. And the spherical form, with perhaps rho, theta, phi. We need 3 points. We need an ordered triple to describe a point in space. We can do that any one of a number of ways. From livephysics.com, we have our familiar three-dimensional coordinates that are rectangular. X, Y, and Z axes, all orthogonal to one another. So we can think of this as our XY plane down here, our familiar XY plane, and then orthogonal to that is our Z-axis. So a point in space is labeled X, Y, Z. We also have cylindrical coordinates, and from the good folks at wolfram.com, we have this graphic of a point in space labeled rho, theta, Z, or, R, theta, Z. We come out a certain radius in the XY plane, and we rotate a certain angle around from the x-axis, and then we go orthogonally a certain distance z, and r theta z gives us a point in space. And this graphic from nps.edu, that's the Naval Postgraduate School, so your tax dollars at work, if you're an American, your tax dollars at work for the Naval Postgraduate School, from which we get this graphic of spherical coordinates, r, theta, phi. Sometimes we call the radius rho. Doesn't really matter. We need a radius and we need 2 angles. And with those 2 angles and a radius from the origin, we can designate a single point in space. Three-dimensional coordinate. When you can do triple integration in calculus in any one of these 3 systems, let me tell you, Bubba, you're doing some math. Mr. X takes the mystery out of math at MrXmath.com.